14.6, apply some indifference formulas.
Are we skipping 14.5?
Yeah.
Oh, okay. Really confused, like, we did not know that.
It's 14.5 is write trig functions and models. It's like writing your own graphs
Oh.
from like, yeah, given information.
My question was what horrendous thing was I skipping that was in 14.5?
What she just said.
Yeah, that would have been my question.
All right, so we have some indifference formulas. So the other cheat sheet that I gave you, this is on there. Like, so you could, I'll either let you just use the cheat sheet you already had, or since you've already proven that you know them, I'll just let you bring that to the test. I haven't decided yet. What I may do for the quiz is make you memorize these, and then for the test, just let you have a cheat sheet with everything on it. But anyways, there's going to be 6 of them. They're relatively easy, honestly, because they follow a pattern. So, like, if you can memorize, like, one, the other ones kind of just follow. So it's, I don't know. I don't think they're too bad. I think they're a little easier than a lot of the other stuff. So, so we start out with sine of A plus B. And this is equal to sine A cosine B plus cosine A sine B. Then sine of A minus B is equal to sine of A cosine B minus cosine A sine B. So the signs are the same. So if it's plus in here, it's plus here. If it's minus in here, it's minus here. And A and B are just angles. So it'll tell you that an angle is like, it'll say like the sine of 75, and you have to figure out what two known angles add up to give you 75. So we would use like 45 and 30, basically. And then that's what gets used in here. So that sine, cosine of A plus B is cosine A cosine B minus sine A sine B. Cosine of A minus B is cosine A cosine B plus sine A sine B. So these ones, the signs are opposite. So when it's cosine of A plus B, it's minus inside, and when it's minus over here, it's plus inside. So a sine and cosine, because tangents looks very different. Sine and cosine, I always remember sine comes first, and when it's sine and cosine. When it's cosine, it's the two cosines and then the two sines. So, and it doesn't matter which order they, like, cosine A and cosine B, it doesn't matter which one's which. Like, if you choose A to be 45 and B to be 30, or A to be 30 and B to be 45, like, that's not going to change your, like, final answer. So, it doesn't matter, like, how you, the numbers that you pick, because they won't be given to you. So, you have to pick. And then, like, if you had something like, I'm not going to be able to give a good example right now, but if it was like a big number, sometimes there are multiple like combinations that you could use to get like the same value. As long as they're known values off the unit circle, you could pretty much use whatever, or like you could use a subtraction one instead or whatever. So then tangent, these ones are fractions. So of A plus B, it's going to be tangent of A plus tangent of B over 1 minus tangent of A, tangent of B. So the nice thing with tangent is it's all tangent. What you're going to see is it's going to be the same sign on top, opposite sign on the bottom. And then tangent of A minus B is tangent of A minus tangent of B over 1 plus tangent of A, tangent of B. So the top sign is the same. Bottom sign is opposite. And again, I'll reiterate that A and B have to be known angles. From the unit circle. Now, sometimes there will be the reverse of a problem where it will give you this side, the right side, and you have to go back to the left, which is significantly easier. In that case, they may not be known angles. They may be like 98 degrees and 63 degrees. Like, that's fine. But when we're solving, they have to be known because you need to know what the value is that goes with it.